Okay, so today we're going to look at some applications of the normal distribution. One of the first things is college entrance exams or standardized tests. Word standardized is closely associated with normal distribution. This is why tests like college entrance exams or state achievement tests for K to 12 students and advanced placement tests are often called standardized tests. Scores are assigned in a way that forces them to follow a normal distribution, with a mean and standard deviation that are consistent from year to year. Standardization also allows people like college admission officers to directly compare an applicant who took the ACT to an applicant who instead chose to take the SAT. Standardization allows us to compare individuals from different groups. This is among the most important applications of the normal distribution. We'll look at this and other real-world uses. So, there are two ways to compare two data values from different groups. We can use z-scores and we can use percentiles. These two methods will always give consistent results, meaning that they won't find, for example, that the first value is better using z-scores, but the second value is better using percentiles. So it is more comfortable for you. So, according to a graduate management ambition council, the mean score on the GMAT, which is a graduate school entrance exam for business management, is 565 with a standard deviation of 116. For the LSAT, law school admission exam, Kaplan informs us that the mean score is 150 with a standard deviation of 10. So what is the z-score? And that should be GMAT, score of 715. Well, remember, z equal to x minus mu over sigma. In this case, x is 715. Mu with a GMAT was 565. And our standard deviation was 116. So that's 150 over 116. 150 divided by 116 gives me 1.29. And typically we want to round z-scores to 2 decimal places. So what this is saying is this grade of 715 is 1.29 standard deviations above average. So this person did better than average. Okay, at what percentage or percentile is an LSAT score of 166? Okay, so this one's a little more complex to work. Let's find the z-score. So we have our z-score equals 166 minus 150 over 10. This gives me 16 over 10 or 1.6. So I don't see where is that. Okay, so upon further research, the book has some information on using a computer to analyze these scores for percentiles. So we're just going to go with these scores. Without the data list, we don't have the ability to calculate the percentile. There is a way using some software that the book mentions, but is beyond the scope of what we want to do in this course. So now I'd ask, which is better, a GMAT score of 650 or an LSAT score of 161? So what we would do is look for the z-scores of each of these, because you won't be able to have a computer on the exam. So we'll just practice what we know. So X is 650. The mean is 565. Standard deviation is 116. So here, what do we have? 85 over 116. Doing our calculator. 85 divided by 116 gives me 0. We want to go to 2 decimal places. Get in the habit of doing that later on if you take statistics. That is the standard. And now looking at our LSAT, we have a score of 161. Our mean score is 150. And our standard deviation is 10. Now I'm looking at 11 over 10, which is 1.10. So which is better, being 0.73 standard deviations above the mean or being 1.10? It would be the 1.10. That's further above the mean. So this would be the better score in relation. So let's go back to our coin flipping. In the beginning of the previous section, we saw that the number of heads we get when we flip a coin 100 times is distributed normally. It can be shown that if n is the number of flips, then the mean of the distribution is n divided by 2, and the standard deviation is the square root of n divided by 2, as long as n is greater than or equal to 20. So for 100 flips, the mean of the distribution is 50, standard deviation is 5. So let's flip a coin 144 times and count the number of heads. What is the mean? Well, we flipped it 144 times. So our mean is 144 divided by 2, which is 72. What is the standard deviation? Well, our standard deviation is the square root of 144 over 2. Square root of 144 is 12. So we have a standard deviation of 6. Okay, again, we can't do a percentile, so we're going to do a z-score. So we flipped 81 heads. What's our z-score? Well, z equals 81 minus 72 over 6, which is 9 over 6, which is approximately 1.33 to do 2 decimal places. And that finishes up section 8.7.